All right, you guys, it's Mrs. Applegarth. I am making a separate recording for the second part of Chapter 8, Section 3. The first one has both parts in it, so you can watch one and get both of them, but I am also going to separate it out. First thing I want you guys to write down is what it means to solve a right triangle. So when I ask you to solve a right triangle, I want you to figure out all the measures of the angles and all the side lengths. So that's commonly going to be in the instructions. It'll say solve this right triangle. The second thing we want to talk about is inverse trig functions. So this is how we get the angle when we have the ratio. So it's used to find angles when the sides are known. So let me show you the inverse trig functions, and for that we need a calculator. So go ahead and get your calculator out. It's important right now to do these with me. It's simple and it's not going to take you too long. To make sure that your calculator is set correctly, make sure you're in degrees, and then my calculator in particular, it likes to take the number before I do the inverse trig. And then my calculator also has an inverse button, but a lot of times it doesn't say inverse, but it says second, and that's how you get to the inverse functions. So we're looking for the little guy that has the -1 on it. So let me do these 4 examples for you so you can see how to use your calculator and do it on your own. So this question is asking us what angle A has a ratio of opposite over adjacent that equals 0.7. So we are going to put that in our calculator, inverse tangent of 0.7, and what it's going to give out to us is an angle. Make sure you're in degrees. So my calculator likes the 0.7 first, and then I'm going to go inverse tangent. So my angle is, rounding to the nearest tenth, is 34.99. Well, to round that to the nearest tenth, so it's going to be 35.0. Looks like an 8, so I will fix that. 35.0 degrees. And that's what A equals. Angle A is 35.0 degrees. All right, so let's look at and do that with sine. So to find B, we're going to take the inverse sine of 0.9. Let me show that on that. This is all this is. It is just straight calculator work. No work done by me, except for the carpal tunnel I'm getting to typing it in. 64.15, that 5 rounds the 1 up to a 2, so 64.2 degrees. We're going to do this with C. So C is equal to the inverse tangent of 5.4. Calculator again. My calculator likes it first. If you have some calculators, you have to do the function first. Mine likes the other one first. 79.5. 79.5. And lastly, this one here, D is going to be the inverse cosine of 0.1. So what angle has a adjacent over hypotenuse ratio equal to 0.1, and we find that by going inverse cosine, 84.3 degrees. Okay, so let's go ahead and apply the solving a right triangle. So we have these 2 triangles here, A, B, C, and we are going to find this missing side, and these missing angles. So the way this brings in all the information we've been learning this school year is just mind-blowing. So just so I can get a more precise writing. Okay, so we can find C super easy. We just go 2 squared plus 3 squared equals C squared. And I know you guys are like, this is Pythagorean theorem. This is not trig section. And I was like, I know, but we're bringing it all together. So bear with me. So 4 plus 9. You're like, Miss Avogarth, I forgot everything there was to know about Pythagorean theorem. So 4 plus 9 is 13. And then our C is the square root of 13. Yay, we have it. Woohoo! It's a big deal. So now we're going to find angle A. So angle A, and here's my recommendation to you. When deciding on which trig function to use to do the inverse and find the angle, I recommend always using the one you have solid information on. So just in case I did my numbers wrong, what if C were wrong? If I used 2 and 3 to find angle A, I would get the right answer for A, even if I completely botched up C. So, and then it is actually easier to use whole numbers like 2 and 3 than it is to use an irrational number like root 13. So whenever we have to make those decisions, I vote for the easiest decision making. So when we're looking at these, we've got 3 is the opposite, 2 is the adjacent, and root 13 is the hypotenuse. So I really am going to use 2 and 3. So that is opposite and adjacent, and that's tan. So we can say the tangent of angle A is equal to the opposite over the adjacent. So we know that angle A is the inverse tangent of 3/2. So we just get the calculator out. We go 3 divided by 2, and then inverse tangent. 56.3 is equal to 56.3 degrees. And then now we need to find B. We are going to use triangle sum. What? Miss Avogarth, triangle sum was so last semester. I know, but bear with me. Triangle sum that says that all angles in a triangle add up to equal 180. So we've got angle A, which is 56.3, our 90-degree angle, and angle B all add up to equal 180 degrees. So add 90 to that. So 146.3 plus B is equal to 180 minus 146.3 from both sides. Oh, Miss Avogarth, again, with the algebra, living in geometry land. How dare you? So 180 minus 146.3 is 33.7 degrees. And then we have all the sides, 2, 3, root 13, and we have all the angles. 56.3, 33.7, and 90. And let's go ahead and highlight those so that you guys can see them a little bit better. So we have root 13, we have 56.3, we have 33.7. Okay, next problem as well, solving this triangle. So we have this angle H right here. We don't have side G or side H, and we have 13, which is that side right there, but we don't have side G. So let's go ahead and do the easiest one first. Let's find angle G. So when you add them with 90 and 25, equals 180. So 180 minus 115 is 65. Okay, so angle G is equal to 65 degrees. That is one of the things that we're looking for. Yay, we found it. Score. All right, so the next thing that we're gonna find, let's go ahead and find G. Okay, so we're gonna use H just in case. I feel pretty confident about G, but just in case it's late in the day and I made a mistake calculating the degrees, I'm gonna use the one I know for sure that has no error because they just gave it to me. So we're gonna use H as our reference. Let's go ahead and find G first. Well, let's label all these. This is the hypotenuse. This is the opposite. And this is the adjacent. Okay, so we want, we're looking for G first. So we have the hypotenuse and we want the adjacent side. So the one that has adjacent and hypotenuse is cosine. So we're going to go cosine of 25 degrees equals adjacent over hypotenuse. And we're going to do a little magician work here. Put the cosine of 25 over 1, and we're going to cross multiply. 1 times G is G, and the other guy is 13 times cosine 25 degrees. Let's do some math on that. 13 times the cosine of 25 degrees is 11.8. So G is 11.8. Okay, we could use Pythagorean Theorem to find H, but because I want to make sure, what if I made a mistake here? My calculator wasn't set right. I would have to use G that I calculated to get H. So a more precise way would be using trig one more time, using the opposite and the hypotenuse, and angle 25, which is sine, is the opposite over the hypotenuse. Okay, so this way they gave me 13 and they gave me 25, so I'm not using any numbers that I've calculated, so it really reduces our error. 1 times H and 13 times sine 25. $13 due to my calculator is times sine of 25 is 5.5. Okay, and that captures all our missing values. We found G, we found little g, and we found H. Okay, so this is the answers from the previous 8.3 assignments. This is the answers from the current 8.3, this part 2 8.3 assignment. So go ahead and pause, check your answers. And make sure you do it right the first time.